Here's the solution to day 3, problem 1. A tower has a diagonal support cable. The cable is 100 meters long and attaches to the ground 20 meters from the base of the tower. Sketch a diagram. Well, let's say that this horizontal line represents the ground, and for a tower, maybe a simple rectangle shape. And to help support this tower, against the wind, there is a steel cable that connects to the tower someplace. In this case, we're interested in how tall the tower is, so let's to make our math simple, let's attach the cable at the very top of the tower. And then we're told it's a diagonal cable, so it comes down diagonally and then attaches into the ground right there. And we're given some measurements. The cable is 100 meters long. So that line right there, that side of this right triangle, is the 100 meters. And the cable attaches 20 meters from the base of the tower. So it's the bottom of the triangle that gets labeled 20 meters. And what we don't know is how tall is the tower? Or in terms of this right triangle shape, how long is this side of the right triangle? Okay. Question B, use the Pythagorean theorem to find that. So a squared plus b squared equals c squared. In this drawing, the shortest leg of the right triangle appears to be this side labeled 20. So 20 gets filled in for A. This side here, the one we do not know, let's call B. And so in our formula, that stays as the variable B. And then for the letter C, fill in 100. So here's an equation involving the variable B. If we solve this equation for B, that will figure out the height of this tower. So first thing to do, we need to solve for the B term. We need to get the B term alone. Because right now it's not alone. It has 20 squared added to it. Let's subtract the 20 squared. 20 squared, subtract 20 squared makes 0. And the b squared gets dropped straight down. So now the b squared is alone. Over here to the right side of the equation, we need to figure out 100 squared subtract 20 squared. (100 squared subtract 20 squared). 9,600. Now to remove this exponent and truly solve for the variable b means we need to do square root. So square root of b squared is equal to square root of 9,600. b equals, now we need to find out the square root of 9,600. So square root 9600. Enter. 97.9, but this next digit is 5 or higher, which is going to cause this to round up, which means let's round this to 98.0. And this one is measuring in meters. And so the height of this tower is 98 meters. Now day 3, problem 2. You invest $60 in a savings account that earns 0.25% interest, compounded monthly. If you make no additional deposits or withdrawals, what will be the balance after 5 months? Hint, use the compound interest formula. So our principal amount that we invested is $60, and then the interest rate, 0.25%. Remember to change this from percent form to decimal form by moving 2 spots to the left. That's going to make 0.0025. That's a pretty small decimal number, but that is what sorts of interest rates that you get for savings accounts lately. They don't make very much interest in the current economic environment. Now, variable n is the number of times it's compounded. We're told monthly. That means every month, which is 12 times per year. In the exponent, the letter n again, so 12 again, and then t, the time in years. Well, we don't leave our money in there not only for one full year. It's only in there for 5 months. 5 months means 5/12 of a year. We want to type this in the calculator. And when we type this in, if we cross-cancel those 12s in the exponent, we really only have to type in an exponent of 5, and that'll just save some typing when we type this in. So let's type this in and see what we get for A, the amount in our account. 60 times 1 plus 0.0025 divide 12, close the parenthesis, exponent 5. $60.06. So we've left our money in our savings account for 5 months and never withdrew any of it, and it earned only 6 cents of interest from the bank in that 5 months. And that is reality for savings accounts. So if you ever come across some money and you can find an investment that earns you more interest than what a savings account does, then you might consider using that other type of investment.